Good evening, ladies and gentlemen. Thank you for giving me a voice. I am my name is Gawel Solosky from Bingo University. I will today talk about algas, production from this feed by hydrogen. The enzymes my talk today would be mostly based on article on fuel of 346 volume. The article was written by international team from Taiwan, Saudi Arabia, and South Africa under lead of Professor Ardo from Malaysia University of Technology. My topic of present titled was Reviewing Biohydrogen Production from Microalgal core cells through fundamental mechanisms, enzymes, and factors that engendering new challenges and prospects. Hydrogen is a promising carrier, future replacement and conventional fuel. It is seen as the most cleanest fuel because combustion doesn't produce carbon dioxide, so only clean. The trouble is only with storage. But only so we need to produce renewable and microalgae are one of the feed which cultivating microalgae capture carbon dioxide, reducing it, so fighting with the greenhouse effects. Lipids can be a good source of biofuels, even to fuels and lubricant that helps biofuels to be replacing conventional matter without any significance for engine. Because most troublesome is that, for example, bioethanol cannot be used in ships or some bigger engines or in aeroplanes. Therefore, other like butanol, biobutanol, or fatty ethyl ethers are very important to use, to apply, and argas as good lipids are good feeds, and rest, which are not to biofuels, can be feed product fermentation to optimize hydrogen production from their waste. There are two similar algas. There are micro and macro algas. According to this article, is based most only on microalgae because they are much seems to be less invasive than algae and less more easily to remove if come to the fresh water. And microalgae catch much carbon dioxide, and this is the other additions. According to bacteria, most common is lipids are mostly for Chlorea vulgaris, and these are contained with high production of concentration of proteins. And spirulina maxima is the best for production of due to high possession of proteins. This is the good plant because algas, you need to remember, are plants. Are good, however, bacteria kinds of plants have even 70, and this percent of proteins that are valuable for pharmacy as astaxanthin, for example. One of the method of hydrogen is biophotolysis. The biophotolysis first can be used as microalgae which grows, can produce hydrogen by biophotolysis, and this biophotolysis depends on light. That is the variable, so not so stable and so durable like dark fermentation, but some has, and this hydrogen can be used. The water can not clean because this microalgae can the salt absorb some salts, clean the water from heavy ion salts for the iron, cobalt, lithium. And then what is not clean then can be used as a substrate for microbial electrolysis, similarly after dark fermentation. The photosynthesis requires in algae is using splitting of water due to presence of sun. It also converts during this photosynthesis or some organic matters taken from water. So this is the important feat. And this can be used direct on indirect with its two-stage, which is much more slower. And both requires in both cases, in case of dark fermentation and for biophotolysis, enzymes are iron enzymes. So addition in both cases, little iron is suitable. And then we have the photosynthesis and photosystem, water, and this due to iron is breaking of water and producing hydrogen. In case of dark fermentation, breaks lipids or sugars into hydrogen, which is added from rest of this microalgae. And this shows how these microalgae can be generally of many sources. So the idea is such that it comes by water. First, these lipids, these microalgae take some waste, and this wastewater comes to hydrogen as dark fermentation, produce some hydrogen, and again some way treated water is coming. Of course, there is also some before after this treated water, which can be microelectrolysis cell, and this showed us that this is unlighted. And this shows us a method of dark fermentation, of what is an optimal method of hydrogen production for many sources, and cleaning the water, and algae capture carbon dioxide, which is quite big problem. So these show very good matter. The uh, professor proposed, Professor Ardo proposed using Enterobacter due to high resistance to oxygen, because Clostridium are quite oxygen sensitive, however not much. But as the reason that this resistance and little bit modification is more important to use to have more stable bacterial layer for dark fermentation as to obtain method for stable and long-term hydrogen production. He also proposed method that we can combine also with photofermentation, which again is sun related, which is can use also after dark fermentation carbon organic acid or never wastewater, and also can cooperate with algae. But also is photofermentation has wider substrate variety than dark fermentation, because dark fermentation is sugars and lipids, and only if we dark fermentation can produce higher if we have genetically modified. While photofermentation can convert also carbonic acid like acetic, so waste for dark fermentation or more complex material without any modification. But is very sensitive to light, and because of light is sun is not stable on the time. This cannot be photofermentation used as 24 hours like dark fermentation of hydrogen production. The case of another is storage method. So here Professor Ardo doesn't shows that is ammonia and Haber process. So with Haber process, this method could be much more affordable. So that's all for today. For this topic, thank you very much for listening to me.